Hi, welcome to lesson 4.01. This is the first lesson in packet number 4 for biology, energy and living organisms. And so what we're going to do in this packet is we're going to talk about what kind of energy do living things need? Where does it come from? And both for plants and for us. So we're going to start off with the first 2 pages, which are pretty much review. We've talked about them either earlier in this class or you would have talked about them earlier in other classes. So let's start off with this fellow right here, and hopefully this looks familiar to you. Can you tell me what this molecule is? If you maybe you can read the fine print, but if you can't, it is ATP. So this is adenine. It's adenine triphosphate. You don't have to know that, but the triphosphate's what's important. Phosphate, phosphate, phosphate. This is adenine, that's ribose. Where do we say the energy lies in ATP? That's right, in the bonds. So the first bond, bond number 1, we said was like a $100 bill. It's got a lot of energy. The second bond has a little less energy. By the way, the abbreviation for energy is a capital E. And finally, this bond, so we said this was like a 10. And then we have this bond, and that's like $1. It's not worth much. If you crack this bond and you release the energy, you end up with this. You get this phosphate floating around over here, and you get I'm just going to do that. So we get this phosphate broken off if we break the bond. Well, this guy has 2 phosphates. What's our abbreviation for 2? Did you say di? Or not our abbreviation, our Latin prefix. Did you say di? This is ADP, adenosine diphosphate. Well, what happens if I crack this bond? So if I crack this guy, then I get 2 phosphates floating around out here. This is a MP. Any guesses what the M stands for? Mono. This is adenosine monophosphate. We don't see this very often, but we see this a lot, and we're going to see it a lot in this chapter. Well, we keep talking about energy. Take a second and think about how many different kinds. Think about, first of all, when you hear the word energy, what comes into your mind? Did you think the ability to get a lot done? So if you have a day where you have a lot of energy, you can do a lot. Maybe you said it is what powers your car. Maybe you said the sun is energy. Energy, we're going to talk about energy for a little bit. Basically, for biology, in physics, we talk about different forms of energy being able to do different things, but energy is the ability to do work. Now, that might sound kind of weird to you because you're like, well, yeah, I mean, I get if I go to my job. We're talking about work from a physics standpoint, and if you come to physics, we'll talk about that a little bit more. Right, the other thing I'd like you to do is I'd like you to think about the number, all the different kinds of energy you can think of. If you need to, pause the video. All right, maybe you said the sun. Maybe you said the sun. And that's true. So that's a type of, it provides a couple of different kinds of energy. Maybe you said a stove. So maybe you said, let's make heat red. Maybe you said the energy to get something done, so you're talking about movement. Well, what kind of energy is ATP? What do we call this? If you had seen this diagram before you came to biology, would you have called that a chemical? Screen yet. So these are all types of energy. And it turns out that within each of these, we could come up with lots of examples. So we're going to kind of do circles here. We're going to make little energy circles. Well, why did I do this? Because energy, maybe you've heard of the law of conservation of matter. It's actually the law of conservation of matter and energy. And it says that energy cannot be created or destroyed it can only change forms. And that's what happens. So when we eat our lunch, we ate a hamburger, or let's go back to our piece of pizza. So we ate our piece of pizza. Our body breaks down the food and it converts it into two different energies. So I take that chemical energy I had for lunch, part of it goes into heat. You're warm-blooded. Your body keeps a temperature of 98.6 degrees. Actually, it's closer to 97.8. We're evolving, but we'll talk about that later. And maybe you need to walk down to the vending machine because it's 2 hours after lunch and you're hungry again. So your body's converting it into heat and it's converting it into movement. Well, where did the chemicals that you took out of your food come from to begin with? Let's come down here to our food web. So if we could put us, let's put people over here. People. So do we eat chicken? Yep. Do we eat wheat, which is a grass? Yep. So where did our energy come from? So we just said we've got a lot of this going on and we've got chemical energy. Chemical energy. Okay, well, if it came from the chicken got its energy from eating a grasshopper, which was chemical energy. And we come down here and the grasshopper got it from eating a grass, or maybe we go straight to grains. Where do the plants get their energy? Aha. So we get to the bottom of a food web and we see that the energy here gets converted from solar energy into chemical. So plants provide the basis for the food web because they're the ones that are taking the energy from the sun and converting it into here, which you can use and you can convert it here and here. By the way, plants also have to do this. Plants have to convert their chemical energy into things that they need in other ways. So what do we call that when an organism can generate its own chemical energy? Do you remember the term? Let's go through a vocab review, and we're going to make this a standalone. We're not going to do 2 pages. We're going to make this energy page a standalone. They're called an autotroph. And in this case, for plants, we're talking about photoautotrophs. So they convert solar energy. But what was the other kind of autotroph we talked about? Yep, chemoautotrophs. So if there's no sun, some organisms can convert different chemicals into ATP, like different chemicals into ATP. Now, we're not autotrophs. We get our food from a couple of different places. Do you remember what the term for that? Yep, that was heterotroph. And this is our main form. So this, what are our takeaways? All right, so to sum up, we're talking about how energy is needed in living things. There's different kinds of energy. There's solar energy. Let's write that in here, solar. There's heat, there's movement, there's chemical, and each one can go into the other, so they can change forms. Right here. I'm gonna get out my highlighter. And we said it's the ability to get something done. The main form of chemical energy that organisms use is ATP. So this is our chemical energy. But where does it come from? Well, if you follow our food pyramid back, we get down to the bottom here and we have organisms that are converting solar energy into chemical energy. Those are our photoautotrophs and our chemoautotrophs. And what we're going to learn in this chapter is, first of all, we're going to learn two things. How do the autotrophs get this done? So this is number one. And then number two is how do humans, or how do we, or any animal, convert this chemical, use this chemical energy to produce. And we start with a different chemical, and it goes into ATP. So where does that come from and how do we use it? So those are our main topics for the chapter. All right, that gets us started. Thanks for watching. Have a good day.